Welcome to Cloudy with a Chance of Podcast. I'm Meteorologist Kirstie Zontini.
And I'm Chief Meteorologist McCall Vrydaghs.
We are a weather podcast and science podcast here in Dayton, Ohio. So if you have not watched us before or listened, welcome to the show.
Yeah, we have a lot of topics here on Cloudy with a Chance of Podcast that range from what's going on in the weather that day to astronomy to earthquakes. And today I feel like is a topic that has been asked of us many, many times in our daily life and in our career. So we wanted to bring in a specialist to really get down into the nitty gritty.
Yes. So our changing climate is a big thing, and it's something we don't want to ignore, but we want to provide as much information as possible. And so I was very lucky during my education at Ohio University. I had a wonderful professor, a Dr. Ryan Fogt, who was our climatology professor. Not only was he able to really help give me some good ground basics, I guess, of what climatology is, but we also did some current studies, and he is a scientist. So not only is he specifically studying climate, he also knows a lot about meteorology, which is daily weather. Climate is the big picture. We talk about that a lot, but he's also done a lot of research himself. So I just want to bring Dr. Fogt on right now and have you do a little introduction for us. How long have you been at Ohio University?
Well, thanks, Kirstie and McCall, for having me today. So I've been at Ohio University for now 10 full years, and this is when I started my 11th year. Came here in 2009, fresh off the press, so to speak, with my postdoc, and then jumped right into teaching. And I think you're one of my first group of students, Kirstie, and so things have changed quite a bit, not only in the way I'm teaching here, but with the climate, of course, too.
Yeah. So a little bit of, I guess, background for everyone. We've talked about this a lot, especially on television, but weather is, the daily picture. It's the snapshot. Climate is the big overall picture. It's the trend. So it's not just, it was hot yesterday, it's cold today. That's weather.
Yeah. And I've used this analogy before that someone else told me that the daily weather is more like your mood that day, where climatology and the climate is more like your personality. It's constantly evolving. It's not one way or the other, but your day to day is what somewhat plays into the climate. You agree?
Absolutely. Yeah. And I tell my students that climate is what you expect. It's like the average kind of conditions are, and weather's what you get. So there's an expectation that it's going to be warm in the summer and cold in the winter, but this winter is quite different, right? We've been a bit above average this winter and a little bit drier, not as much snow. And that's part of these natural weather variations that are happening with changes in the jet stream and on those things. But if you look at how the jet stream is evolving over many decades, then you're moving into climate and climate change.
Wonderful. So let's, I guess, start off a little bit with your background. So we say people hear of meteorologist, but I don't know if they oftentimes hear about what a climatologist is and what a climatologist does. So why don't you just explain that for us?
Sure. So my area of focus actually is in the Southern Hemisphere. I am interested in understanding patterns of variability in the Southern Hemisphere atmosphere and ocean, and a little bit into the ice, and why they're changing and what's causing those changes, and perhaps how they might change into the future. My passion actually is Antarctica. I've been down to the ice 3 times as a grad student at Ohio State, and I look at patterns in Antarctic climates in the atmosphere, and how they're causing the ocean and the ice around Antarctica to change, and how they're causing the grounded ice on the Antarctic continent to change as well. And so go ahead.
Sorry. Oh, no, you go ahead.
So I use a blend of observations that are collected down in Antarctica from weather stations and staff bases, research bases, and climate models and reconstructions to help me to understand past climate and put the current changes in that context of a longer picture.
Wow. So how does the Southern Hemisphere and what's going on down there climatologically impact us in the Northern Hemisphere?
The biggest connections are through the ocean and through the ice. So parts of the ocean circulation can extend through both hemispheres, and that's primarily in the deep ocean. So changes in what's happening in the Arctic, in the ocean near Antarctica, and the ice melting near Antarctica can influence the ocean. One of the biggest ones, of course, is through sea level rise. So if we're melting ice on the continent itself, ice that's sitting on land, that ice supplies water to the ocean, which changes sea level. And historically, scientists have been mostly concerned about sea level rise from Greenland because of its really fast melting rates and how quickly it's changing. But more attention has been turning lately to Antarctica and melting in parts of Antarctica and how that might influence global sea level. So places along the east coast of the US are experiencing sea level rise, and part of that sea level rise is coming clear from Antarctica.
Wow. Yeah, so I think people sometimes like have a hard time maybe grasping or really getting the fact that something that's happening oceans away, it is impacting us, especially the East Coast, which that is real, that that the coastline is changing.
And it's a constant thing around the entire globe. What's happening on, the western side is eventually going to impact what's happening on the eastern side. During your research, and this is just me throwing it out, I have no idea, have you had an opportunity to travel to any areas in the Southern Hemisphere to do research there on location?
So I've been down in Antarctica several times, and collected data down there and helped install some weather stations that I've used for my own research on the continent. I've also done some forecasting down in Antarctica. My main role down in Antarctica was to work with the team that did the forecasting for all the U.S. operations, and that included flights and stuff around to research operations on the continent, but also flights to Antarctica from New Zealand or from South America to the Antarctic Peninsula. And the model that they used for the forecasting, the weather model they used, it was a model that was tailored to work in Antarctica by scientists at Ohio State when I did my graduate work there. And so I was down there to test it and see how it was working and understand where we can improve it so that we make better forecasts. But I've also had numerous conferences and meetings in the Southern Hemisphere, since most of my work is in the Southern Hemisphere, and been able to meet with really great scientists that you might not otherwise interact with as much because of them being a bit farther away.
So your research and your career, I know, is a small snapshot in the centuries that the globe and the climate has been changing. Has there been any notable changes to you in your research that throughout the many years that you've been doing it that you've noticed changing?
So my current project is on Antarctic sea ice. And we're looking at understanding how Antarctic sea ice is changing and what's driving the changes. And the challenge with that is that Antarctic sea ice observations really are from satellite data. Okay. And we only have measurements from about 1979, a few spotty measurements before that into the early 70s, but really just about 4 decades of satellite data. And it was really puzzling because Antarctic sea ice had been increasing up until recently, and that's in stark contrast to the Arctic, which has been rapidly declining. And then all of a sudden, 2015, 2016 came around, and the Antarctic sea ice plummeted into record lows that it had never seen really in the satellite record, and has stayed down since. And so we're trying to understand better the causes and changes of Antarctic sea ice by putting them in a longer perspective, and to know if this sudden drop that we saw recently in the last 3 years, if that was something that has happened before, and how might it happen again in the future as we move into ozone recovery and greenhouse gases increasing and all these other things that are part of our future.
So you're basically you're working on or able to kind of computer model it out, right? Like you're taking puzzles of what's going on currently and then putting those pieces together to see why or to see what could continue to happen.
Yeah, I'm using some computer models, but I'm also using a wide array of data that is collected not only in Antarctica, but actually, because Antarctic records are also short, data that's collected across the mid-latitudes, places like Australia and New Zealand and South America, and temperature and pressure readings from those stations there can help us to understand how Antarctica might have behaved before we had measurements in Antarctica. And we can use those in a statistical way to figure out and approximate what might have been happening to Antarctica before we had measurements even collected there. And we can I've done that for pressure. That was my previous project, but now we're trying to do that with sea ice and see what was sea ice like before we had satellites around Antarctica measuring sea ice, to know if these changes that we're seeing right now, which are having really big consequences for the penguins and the life around Antarctica that depend on sea ice. How unique are these changes, and are they something that could be due to human activity that we can't detect very well because of deficiencies maybe in the way we're understanding the behavior of sea ice?
That's really crazy, and it's so interesting and so important as well. You know, we need to keep doing this kind of research to figure out what we can do in the future. For people, I guess, maybe that are just kind of wondering day to day when we talk about a changing climate or climate change, even global warming. I think sometimes those are like hot button and people don't want to talk about it. But as someone who studies this, and you are a professor, climatology is one of the courses you teach. So, for just an average person, what are some, I guess, maybe more local ways that we are noticing our climate change, or we have now, and we have data? This isn't just like made up.
Yeah, of course. Yeah. So temperature and precipitation are some of the biggest measures that we would look to see if climate is changing.
Mm-hmm.
Globally, average temperatures have been rising over the last 150 years. The rate of increase has gotten faster more recently. So the last 30 years have been some of the warmest years. The changes have been faster in those last 30 years. 2019 just came off the press to be the second warmest year in record, right behind 2016. In Ohio, we had a warm year as well. 2019 was the third warmest year in Ohio. I'm sorry, it was I think the third or fourth warmest year. I was in the top 5 for sure. It was warmer than 2018. It was also a very wet year in Ohio. 2019. It was the sixth wettest year on record since 1895 statewide for Ohio. And these are all part of changes. We expect temperatures to go up because of greenhouse gases increasing. We expect also changes in the hydrologic cycle, how much rain we might experience. And particularly, we expect to see more heavy rainfall. So these thunderstorms and convective storms, these powerful storms that tend to give us an inch or more of rain really quickly, that aren't so great for agriculture because the rains are just so heavy that it tends to lead to more flooding and flash flooding than it does to saturate the soils and help to promote crops and really a good soil chemistry. So those are some changes that we're seeing here, but they're all there are many things that are happening worldwide that are unique to different regions. And so if you were to think about what's some big impacts in the US right now, you could look in places like Alaska. Alaska had its warmest year on record in 2019. They've seen some of the most rapid changes in climate. They've had melting of the permafrost, which is a condition of permanently frozen soil.
Mm-hmm.
And as that melts, it releases methane, another greenhouse gas that just helps to amplify this process, and also just destroys infrastructure that was sitting on frozen soil. Roads and buildings collapse when that soil melts and becomes soggy. And they've had sea ice loss at the coast near Barrow and on the north shore of Alaska in the Arctic Ocean, where the reduction of sea ice in the Arctic has led to more soil erosion at the coast and coastline erosion and changes in the fish that they're catching around the coastal waters of Alaska.
Mm-hmm.
And that's even true of the changing in the marine life on the east coast of the U.S. The lobsters and those species have all moved north. And so where you used to get a good catch of lobster, maybe in the New England area, it's now moved up to Maine and starting to go up into Canada. There's just this northward shift in response to where the waters are colder to support that particular ecosystem.
To get down to the basics, because obviously climate has changed. It's changed, since the planet has been here.
Mm-hmm.
But it's so important now because of the impact of humans on this changing climate. And that really breaks down to the greenhouse gases. And someone who is not familiar with what greenhouse gases and why this is so important, can you talk a little bit about what greenhouse gases are and how human activity really plays a big part in what those gases concentrations are and the warming of the planet?
Yeah, the atmosphere acts like a greenhouse. The best example that might be really easy to understand is it acts like your car does in a hot summer day. It allows energy to come in very quickly from the sun, but that energy doesn't escape as freely as it comes in. So energy comes in through the glass of your car, windows and windshield, and your car heats up because the energy doesn't get out as freely as it gets in. It doesn't get out as freely because of the gases in the atmosphere trap or absorb that radiation that's trying to leave the Earth because it's a much longer wavelength. It's a different kind of energy that comes in from the sun. Mm-hmm. And so that energy gets absorbed by the atmosphere. And part of that energy that's absorbed by the atmosphere gets sent back down to the Earth's surface and leads to a warming at the Earth's surface. Some of it goes out to space, some of it comes back down and we feel it down here at the Earth's surface. The confusion is that overall process is actually a very good thing. The fact that the atmosphere traps some of our radiation from the Earth, it keeps our planet habitable. It keeps temperatures above our planet above freezing, right? It allows plants and animals to thrive on our planet. It's a very unique climate. But small changes in the amount of those greenhouse gases, gases such as carbon dioxide, nitrous oxide, and methane are the main ones. They're very effective at absorbing that radiation. So small changes in those gases can lead to big changes in the climate. Because these gases all by themselves sum up to less than 1% of our atmosphere. They are a very, very small part of our total atmosphere, but have a very, very powerful role in our surface climate and surface energy budget.
I think something, I guess, too, for the greenhouse gases, explaining that is really important. But also, I guess, when you were just kind of mentioning how we're like, getting warmer and how, some of the different animals and stuff are trying to migrate up to where it is colder. Are we starting to see, I know we've seen maps that kind of show this, there isn't as big of a temperature variation, or that, we're starting to almost balance out too much, that where is the warm and where is the cold across the globe? Is that kind of what a fear is, or is that what a trend may be that we're watching?
Yeah, we've seen the largest warming right now in the Arctic, globally, and the northern hemisphere over land surfaces. So particularly the higher northern latitudes, so like in Canada, Alaska, Scandinavia, and northern Asia, and then the Arctic. Partly because of different feedbacks and different things that accelerate the rate of warming in those regions. Losing snow, melting ice, for example, can amplify the rate that would warm there locally. But in the US, we've seen a shift in our temperatures. You mentioned, Kirstie, about nighttime lows not being as cold as they used to be. And in fact, there's been a trend in the US that for every record low temperature that we set 2 record highs now. And it's shifted, from being a 1-to-1 ratio of record high to record low to moving to 2 record highs now for every record low that we're setting across the US. It's not that, we won't ever set record lows. Those things can still happen because weather still happens.
Yes.
But it's this shift where we're seeing a frequency change to more extreme heat or prolonged heat and less of this extreme cold.
I think that's a good example as well, because a lot of people will notice when we get a cold snap and then they'll go, oh, well, where's global warming?
Right.
And that's just not the way that you should be looking at it. That's weather. We will always have big fluctuations with temperature, but like you said, it's the overall averages now that we're seeing warming, that the nights just can't get cold or as cold as they used to. Is that a good way to kind of think of that?
Absolutely. And, it would be dangerous to say this whole warm winter that we are having right now is from climate change.
Right.
It's partly because of climate change. Absolutely. It's consistent with what we'd expect from climate change, but it's also due to weather and changes in the jet stream and differences in snowpack over in North America that are all driving this really interesting condition over much of the eastern U.S., actually. And so we're one of many states that have started off pretty warm in 2019 so far. Largely due to weather, but also because of this changing climate.
Yeah, and I mean, when we made our long range winter outlook, it wasn't based on climate. It was more based on what are the global patterns expected as we go into the winter time. So yeah, a part of it perhaps is climate, but the pattern that's been set up is really what we've been dealing with. Now, we've talked about this before. So our 30-year average is what we use to measure what our daily highs and daily lows should be on any in particular day. We're starting to move into that next 30 years. Are you anticipating that we're going to see those numbers nudging up a bit based on the data that we've collected over the past few decades?
Yes, yeah, and I suspect, right now the climatological normal established by the World Meteorological Organization is 1981 through 2010.
Right.
Now that we moved into a new decade, I wouldn't be surprised if we adjust that to the most recent 30-year period, just because what's normal is different now. It is warmer, average across the planet, and it might be better to have a baseline that's comparable to the human experience. Most people are going to remember the most recent 30 years better than they are the previous 30 years. And if you're using that period of 1981 to 2010, when it was on average colder than it is the last 10 years, it makes everything just pop out as even more more warm, right? So I do expect that we will see an announcement made sometime in the near future for that period to move forward, just to reflect the changing climate.
Right. I think it's also kind of interesting. We talk about this a lot as we are trending warmer as a whole. Warmer air can also kind of hold more moisture, and we've had a couple seasons now, at least just kind of connecting with the farming community of, you mentioned it before in the podcast, which was great. We're getting these heavy rain events, and it's not prolonged, but they're sporadic and they're frequent, and then they're producing a ton of rain. And what's also interesting too is at this point now, because the population has grown, we have way more urban areas than we ever used to. So it always sticks out in my mind that we've had some flash flooding in cities that never would have really or hadn't had to worry about that. Part of it is just because it's an urban environment now, so you're not going to have that soil to absorb things, but it's also just like the population is growing, we're warmer, and now that trend, I guess if you can kind of comment, is that trend of frequent heavy rains going to be part of our future?
Yeah, and 2019 was a wet year across the U.S. I mean, especially when you move east of the Mississippi River, east of the Rocky Mountains even, and several states along the U.S.-Canada border, 5 of them had their wettest year on record in 2019. Wow. In a 100-plus year record, they've never received so much rain or snow as they did in 2019. So, and like I said, Ohio was its 6th wettest year. Michigan, just above us, was one of the wettest years. And so it really is this change where we're seeing heavy rain, not this nice gentle rain that would be great for agriculture, right? Where we're just so gently into the rain. It falls so fast that the soil gets saturated very close to the surface and doesn't allow it to penetrate down, and therefore just pulls up onto the surface and leads to local flooding. And yeah, in urban areas, it can where it doesn't drain fast enough, it can just create some flash flooding and problems there as well.
Climate change seems like such a big issue. I mean, it is a big issue, but for the average person, it may feel overwhelming, and that what they do doesn't have an impact on what's going on. But it does. Each and every person can do something to try and stop the warming of our planet. Can you speak to just a few small things that anybody on any given day could do just to help our environment?
Yeah, certainly everything that we do makes a difference. It may not solve the climate problem altogether. I think we do need international policy and strong support for that policy to have some serious reductions in greenhouse gases. But simple things like choosing to walk, bike, or take public transport more often are very effective things that you can do. Using less energy is really great. One of the biggest in the U.S. Emissions from carbon dioxide is from the energy sector, and so if you can reduce your energy consumption or move to more renewable forms of energy, if that's an option for you. Solar is really growing fast across the U.S. Wind is growing very fast in certain states. And so those are renewable forms of energy that have a lot of potential to help reduce our emissions if we were to use them more frequently and across many more states and in communities like Dayton. So I would really encourage that. But one of the books that I like, or groups that I like, is the Project Drawdown group, and they have many solutions to reducing climate change. And one of them that's quite simple is just reducing food waste. Food waste is there's a lot of carbon emissions associated with food waste that you might not consider. For the transportation costs to get it to the market from the farm or from where it was stored to your plate, that carbon emission is something that everyone does by eating. And if you're just throwing that food away, then there's also the energy associated with its transport as waste, and then where it's going to go and how it's going to be used after that. So simply reducing your food waste, just taking the proper amount of food, making sure that you're getting the right nutrition in that food without having to have too much of it, is one thing that we can do to really help fight climate change. It's something that you might have ever thought of, but it's something very powerful.
So no effort at all by that. Just saying, I'm not going to buy too much food, and I'm not going to cook this big meal that only 2 people are going to eat. I mean, that's easy. That doesn't,
and buying as much as locally as you can too is really great. From farmers markets or even in the grocery stores, looking at local areas, a lot of them have marked local produce or local food. And you can, that has a smaller net footprint because it was grown in the community or nearby. And so the transportation emissions from that are reduced. And so you should, it's really great to do that if you can. It might not always be the cheapest form, but sometimes when you think environmentally and about these things, the cost on the planet had to be factored in as well. And so it's not just the dollars out of your wallet, it's the dollars that you're saving also for the planet and your future. And so you're kind of investing in some way when you're buying locally into your future and the future of those that you love.
Yeah. One thing locally that we dealt with was our tornado outbreak on Memorial Day. And we lost a ton of trees. The canopy was completely changed in a lot of our cities. It wasn't just one city. It was, McCall tracked these tornadoes, and it was a huge footprint that you will look at Google Earth image now and we'll be able to see just how much of the trees were lost. I don't know if people always understand how important it is that we replace these canopies in not only urban areas, but just how important a tree is. Do you want to speak a little bit to that about how trees they're able to filter our air, and they really do help when it comes to trying to combat a little bit at least of our changing climate, especially the emissions and stuff.
Absolutely. Yeah. So trees are a natural sink of carbon dioxide, and one of the biggest ones. And so globally, at least. And so, when those trees are cut down, either for urban growth or in a natural disaster, when they're destroyed, unfortunately, you're losing that carbon sink. And so it's great to promote urban green space. It's great to promote green roof projects or things like just simply replanting trees that were lost to make these things neutral or even go carbon negative in the sense that you're taking more carbon now away from the atmosphere than you had without that tree. So and there's a lot of research on this, that there's this green potential that if we all thought about local gardening and growing trees and planting trees and thinking about more green spaces, those are really important ways to sink some carbon and remove carbon from the atmosphere.
I am excited, and this is just a little toot for Dayton, Ohio, but they are Tree City, USA, and they're very much big on making sure that we have a green city, and they've done a lot of things with transportation, making bike lanes and things a lot safer for people to travel in a very green fashion. And hopefully we'll start to see more and more cities across the country hopping on that Tree USA train.
Yeah. So thank you so much for being with us. I think that it can be a heavy conversation, and it can be, like you said, McCall, maybe a little overwhelming to hear, all of these changes, but hopefully people can just stop and think. And like you said, you gave some really good ways that they could reduce their carbon footprint. Is there anything else that maybe you want to leave people with that might not know a whole lot about our changing climate, or any last little thing to wrap things up for us?
Yeah, I like to always in my classes with just a bit of hope. And so if you're a person like me that spends a lot of time in this area and can get discouraged by the way things are headed sometimes, that you continue to have hope. And hope comes in communities like Dayton that are doing great things, and other cities where they have mayors that have signed pledges to be still into the Paris Climate Agreement, and just ways that you see change happening. And I encourage everyone that can feel discouraged about these things to find those glimmers of hope and to track onto them and be part of them, because you can make a change and you can be part of that change. This is not a problem that we're doomed for. I still believe we have time to act, and we should act, and doing everything you can in that regard, and keeping your hope in a moment of chaos is really important.
Thank you so much for joining us.
Yeah, my pleasure. Thank you so much. Thank you.
Wonderful to be able to speak with you. So if you want to listen to this podcast or any of our other episodes, just go to Apple iTunes. We have our podcast there, Google Play, and Stitcher. We also have some more of these video podcasts.
Yeah, if you have a streaming device such as Roku, Amazon Fire, Apple TV, all you have to do is search WHIO. You'll see the little icon just like you would on your phone. Click on it, download it, and you'll see more of our podcasts there. And of course, any other weather videos that we're uploading changing daily. Also, you can check this out over on WHIO.com. Thanks for joining us. We'll see you next time.